In this video, I'm going to demonstrate solving a system of linear inequalities. Let's break down what that means. First of all, when I say a system, that means we're talking more than one. So in this case, we're looking at two linear inequalities. We're going to be graphing inequalities, not just straight lines, not just equations like 3x plus 2y equals 6. So let's look at how we're going to do that. Well, in order to solve a system of equations, we need to take each equation individually and graph that. So let's look at our first one. There's our first equation. 3x plus 2y is less than or equal to 6. Now let's review the steps we're going to do anytime we solve a linear inequality. So step one is to rewrite the inequality as an equation. That is, replace the less than or greater than sign with an equal sign. And let's do that. So looking at this equation, 3x plus 2y equals 6, I notice this is what we call standard form. And when I have an equation in standard form, as opposed to slope-intercept form, the easiest way to graph this is by graphing by the intercepts. And to do that, I first take, let's first find the y-intercept. And the y-intercept is when x is equal to 0. So let's go ahead and solve for y if x is equal to 0. I have 3 times 0 plus 2y equals 6, or 2y equals 6, or if I divide both sides by 2, I come up with y equals 3. So the first intercept is the point 0, 3. That's my y-intercept. Next, I'm going to find my x-intercept. My x-intercept is when y is equal to 0. So I'll have 3x plus 2 times 0 equals 6, 3x equals 6, and dividing both sides by 3, I get that x is equal to 2. That gives me my point 2, 0. And let's go ahead and plot those 2 points. First, let's look at the point 0, 3, and that's my first point right there. And now let's look at the point 2, 0, and that's my point right there. And now what we're going to do is connect the dots. But first we have to remember, if I have a greater than or equal to, or a less than or equal to, I do a solid line. If I have a greater than, or if I have a less than, then I'm going to use a dotted line. Because that means it can either equal that line, or it gets really close to that line, but it never quite equals that. When I look at my equation, I have less than or equal to 6, so I know I'm going to use a solid line. So I'm going to go ahead and connect those dots with a solid line. And that's step 1. For step 2, what we need to do is pick a test point. And what we're going to do is pick a test point. The only thing we have to watch out for is it cannot fall on the line itself. So we need to pick a point that's off of the line. My favorite point to pick is 0, 0. And that's because it usually makes the arithmetic much nicer. Now, I'm lucky in this case I can go ahead and use that for a test point because it's not on the line itself. So let's go ahead and take that point 0, 0, and we're going to plug it into my original inequality. So now we're going back to the inequality. X is 0, y is 0, so I end up with 0 is less than or equal to 6. That is true. Since it's true, what I'm going to do is be shading the side that contains that test point. That is, since 0, 0 makes this inequality true, everything on that side of the line makes this equation true. I could pick this point here, that would be -2, 3, and if I plug that into my original inequality, that would also be true. If, on the other hand, I picked this point, that looks like the point 3, 3, well, let's try that. If I try 3, 3, I get 3 times 3 plus 2 times 3. Is that less than or equal to 6? 9 plus 6. The last time I checked, 15 is not less than 6, so this is false. That means that this point does not make this inequality true, so I would have to shade the other side, which is exactly what I have done. So it doesn't matter where you pick your test point, but if it's true, shade that side. If it's false, shade the other side. And I went ahead and actually did step 3, which is actually shading the side. So again, step 1 is rewriting the equation with an equal sign and graphing it. Let me go ahead and say we're going to graph that. Step 2 is to pick a test point, and step 3 is to shade a side based on the test point. So we've gone ahead and looked at the first equation. Now let's move to the second equation. Alright, so we have the equation y is less than 2x. Again, step 1 says replace that with an equal sign. Now when I do that, I see that this is not in standard form. If I try to plot by the intercepts, if I let x equal 0, then I find that y is equal to 0. And if I let y equal 0, I have 0 equals 2 times x, and x is 0. So that just only gives me 1 point. That's not enough for a straight line. So let's instead graph this using the slope and intercept. This is the same thing as y equals 2x plus 0. That means my y-intercept is 0. So let's go ahead and plot that point. And there's my point 0, 0. Now we'll move by the slope. The slope is 2. Or I like to write it as 2 over 1 because that reminds me what we're going to do is move up 2 and over 1. And we could even do another point. Up 2 and over 1. And now let's go ahead and connect those dots. Alright, so now what I have to do is again go to step 2, which is to pick a test point. But notice this time I can't pick my favorite test point because 0, 0 is actually on the line itself. And, I think I missed something. And this is going to happen to you on an exam. This is a less than sign. It's not less than or equal to. So that means I better not draw a solid line. I have to instead draw a dotted line. If this happens to you on a test, if you're using a pencil, you can just go ahead, exactly what I'm doing now, and erase it. Erase little bits of that line to make sure it looks dotted. And if you're really worried, you can write the note dotted. I sometimes have students do that. They want to make sure that I understand that that's a dotted line. Okay, so now I've got the right kind of line. Let's pick a test point. I can pick anything I want. Let's see, I think I'm going to pick a point over here. I like either letting x or y equaling 0 if I can. So that point is, let's see, 1, 2, 3, 4. That's the point 4, 0. So that's my test point for this second line. So let's go back to the original equation, which is y less than 2x. So y less than 2x, y is 0. 2 times 4, 0 is less than 8. And yes, that's true. So that means this time I'll be shading like that. And oops, I need to make sure that I'm going all the way to that purple line. It's that second line that I've drawn that indicates the half plane I need to solve. So I've got my first equation in black and my second equation in purple. What makes both of these true is what solves the system of linear inequalities. So that means this bit right here is the solution to this system of equations. 3x plus 2y is less than or equal to 6, and y is less than 2x.